All right, we are live. I'm just going to double check and make sure that it looks good. Waiting for it to start. There's a bit of a lag, and it is an ad. Sorry, I always have the Twitch window open on my second screen. So today we're going to have a little bit of a different format. So I was traveling this week, and my flight home got in last night pretty late, and I am very tired. So I am going to, instead of my usual sort of working on a project format, I'm going to be going through and answering questions. So I sent out a tweet asking if anybody had questions for me online before I got started, and it looks like I don't have any takers yet on the tweet, which, like, no big, I got a backup. And if you guys are just joining in, please feel free to drop your data analysis questions, or just, like, I don't know, whatever questions you have in the chat. But until then, we're going to start working on answering questions on this thing, the forum. Oh, I'm very tired. And actually, what I think I'm going to do is change my profile a little bit. Edit it just so it's a little bit clearer who I am. Yeah. Oop. Thank you, Dropbox. There we go. Non-admin. Oh, here's a question. Can I have... Yeah, awesome. Oop. And admin, non-admin, incognito at question mark. Alright, excellent. So now people know who I am when I'm answering questions. And I just have this account rather than my usual account, because I want to make sure that, you know, people's data stays safe and nobody sees nothing they shouldn't, and someone, i.e. me, shouldn't click on places that would show admin data accidentally. So I'm not allowed to enter Kaggle competitions. Well, I can enter, but I can't win, so me having multiple accounts is not a problem. But if you're entering competitions, do not have multiple accounts. They will find you. Okay, a little bit of a drink. Let's get started on some questions. So I am in the questions and answers forum, and I'm going to try and focus on things that are a little bit more technically interesting. So let's see, Mahesh has a question, and it hasn't been answered yet, and was posted 2 days ago. So these are the questions. This one also hasn't been answered, but I am perhaps not the best person to answer computer vision questions, so I'm just going to skip over that one, and maybe some of the other Kagglers will help out. All right, so this person has a problem. I have a scenario where the transactions for a customer go through a series of events. Each of the events has an impact on the dollar value of the customer, which is market driven. Any wrong entry leads to wrong value being calculated. Is there a machine learning to look at the data and identify the errors? The data is temporal in nature, driven by customer, which can have multiple records. All right. So there's a couple things that are going on here. So here we have the data is temporal in nature. So this tells me it's a time series modeling problem, and we need to consider the fact that, like, we don't just have just a bunch of measurements. There are a bunch of measurements in a specific order, and there is time in there. We also see that customers can have multiple records, so that there might be multiple time series for a specific individual. It's kind of hard to tell without sort of a sample data set. So we may have to do record linkage, so figuring out who, who is specific, what's the word I'm looking for? So finding out who... So detecting for each record X, whether that record should be associated with an already existing customer. So sort of like, if this were an NLP task, it would be entity linking. So if they have like a name field and sometimes they misspell their name, that's potentially a reason why you'd have a record for a single person split. But I think what they mean here, and it's a little bit hard to sort of like figure out what people are asking for sometimes without the ability to do like back and forth. I think what they're looking for, what they mean here, is that it's time series and that they have multiple time points for each customer. And then they want to detect the incorrect entries in that time series. And I would call this particular task anomaly detection in time series. So we're going to do what I do, and I'm going to Google this because anomaly detection in time. Yeah, that's what I want. Because a lot of times, especially if you're new to the field, you come and you ask questions and like, yes, you could Google the answers, but you don't know the right terms to use, so you can't get to the point where you can like Google usefully. And also, something that I think about a lot is the fact that my Google results will look different from other people's, just because I have Googled a lot of things related to data science on both my personal and my work accounts. So that's going to change how things are ranked and are relevant to me personally if I'm signed into my account, which I am. Okay, here's a blog uploaded in 2017, so it might be pretty recent. This might be useful. So I see that it's Azure, which is Microsoft's web platform, which is not necessarily a problem, but it talks about a specific module. So this may be a service that you can purchase from from Microsoft in order to detect time series anomalies. And I think that might not be as useful for this person. Oh, here we go. Here's a paper from Google. Detection of anomalous drops with limited features and sparse examples in noisy, highly periodic data. So I don't think their data is necessarily periodic based on the way they phrase their question. So periodic means that it repeats itself, right? So like sound waves are periodic because they are composed of multiple repeating waves that are, composed into a complex waveform. And there's repetition in that waveform. Customers can have multiple records, but they're not necessarily evenly spaced. Okay, let's take a look at this paper. Google uses continuous streams of data from industry partners to deliver accurate results to users. Okay, so this is, just looking at this, I can tell that this is very periodic data because it has sort of like at regular intervals little spikes and divots. And this is the sort of data you would expect to see if you were sampling from a system that had a lot of repetition in it and you were sampling at a relatively high rate. So you had a lot of samples per time unit. And based on the way that this question is phrased, it leads me to believe that they have relatively few incidents per user. All right, let's see. Time series anomaly detection algorithms. Current state of anomaly detection techniques in plain language. Yeah, that sounds about what this person's looking for. They're looking for errors. Let's see, so different outliers. So those are things that are sort of outside the range of that you would expect for your data points given the data you've already seen. Or when you see a change over a period of time, so some sort of temporal change, you see an event and that changes the data signal you're getting. And then seasonality, so like if you think about temperature, there's a day-night cycle, so it's warmer in the day and cooler in the night, but also changes over seasons. So the night in the summer is going to be hotter than the night in the winter, and the day in the summer is going to be hotter than the day in the winter. So you have sort of a short-term oscillation and then a long-term oscillation. Which you would want to control for. But the way they phrase their question, I don't think that they should have seasonality. necessarily. It doesn't seem like they have, really high fidelity data where they have a lot of samples. I think this is going to be a good blog post to help this person out with. So let's write them a helpful answer. Hi there. It sounds like you're interested in detecting unusual events in a time series where you have a distinct time series for each customer. Unusual. There we go. Let's spell that correctly. I would call this task, trying to move my cord out of my way so I'm not trying to type over it, time series anomaly detection. Generally, time series anomaly detection. And I'm going to point them towards, I don't think this is going to be helpful because this is for highly periodic data, and this covers less periodic data as well, because you can use CART with anything. CART is classification and regression trees. CART, it's an acronym. ARMA, if it's time series data, yep, absolutely. Exponential smoothing might work. Again, it depends on how periodic the data is. And then neural networks. Yeah, I think that's pretty much all the things. This blog post has a good overview of some different techniques for anomaly detection in time series. Your problem will be harder the fewer events you have per customer, and the less like customers are, and the less similar customers are to each other. So usually when I'm answering a question, so this is the fewer events is the sort of fidelity I was talking about with a time series thing, where the number of samples you have. And then if customers are very dissimilar to each other, a customer themselves could be an outlier. And if you treat all of your data as a single data set and ignore the effective customer because you're trying to get more data points, then you may just end up marking, a specific customer as an outlier. So I'm going to take some time and put this into sort of, clearer language. And I also like when I'm answering a question like this to give a clear example. So if you have only two customers and they are very different, one only buys inexpensive flowers and the other only buys cars. No, I don't think that's a good explanation, because so this is setting up in this person's mind the idea that there might be a lot of let me make the text bigger. There might be a lot of homogeneity within customers, so a specific customer's transactions may be very like each other, and that's not necessarily the case. So let me take another tack in trying to answer this. If you only have one or two events per customer, for example, you won't be able to form a good idea of what each customer usually does. Get a drink. You want people to form a good idea of what each customer usually does, which means that it will be harder to detect if they do something unusual for them. One way to get around this would be to combine data from multiple customers and look for the events that are very unusual when you consider all the customers. But if you happen to have a customer that is very consistent with their earlier behavior and very different from usual, that is very consistent with their earlier behavior and very different from the other customers, you may end up detecting errors that are in fact normal for that customer. Good luck with your project. All right. Let me preview this to make sure it looks good. Yep. All right, let's post it. Question 1, done and done. Yeah. So a lot of times with questions, I find that just like knowing what to Google is the thing that's the, bottleneck for people. So, all right. Oh, here's a question. Fresh off the question truck. I don't know. All right. Deduplication machine learning algorithm. I've been working with data analytics industry for quite a long time, and the major issue most of the time, I will answer this question. George asks, I have several megabytes of literature masterpieces in English and would like to segment each sentence and then produce embeddings for deep learning training. What tools do you recommend for me? George, do you use Python or R? Or neither? I mean, if you're doing deep learning, you probably are using one of the two. There'll be probably a little bit of a delay while the stream catches up. Segment each sentence. While I'm waiting for George to get back to me on that, Python, okay. I wonder if Botnik has a GitHub, because they might have some fun examples. Yes, so for George uses Python. Okay. So are you looking for embedding each sentence or doing word level embeddings? Oh, actually, you know what? I could type this and we could get rid of the lag. Are you looking to embed individual words or whole sentences? The reason I've come to Botnik is that they do a lot of text processing stuff. Do they not have a GitHub? Sentence level embeddings. All right. Yeah. So, So the reason I'm sort of hemming and hawing right now is that there's sort of some disagreement within the NLP community about whether or not you should embed at the sentence level or whether you should stick with word level. Oh my goodness. Some books just fell off of the desk over my computer and onto my head. I'm fine. Anyway, so there is some disagreement in the NLP community, and apparently my bookshelf, whether or not you should actually embed sentences. And I'm assuming, just with no other background, you have a really good reason for wanting to do sentences. Sentence embeddings might capture more about style, like a specific writer's style, than a word level embedding might do. I think there's something in NLTK. Sentence level embeddings. Sentence classification. Augmenting. Oh, that might be useful. So let's take a look at that. No, I don't think it was an earthquake. Sorry, it fell right next to the mic, so that probably sounded really awful. I think it's just me, like, jiggling my desk. Although I live in Seattle, so it could very well be an earthquake, a little small one. Where was that thing? I think it was context. There we go. So bidirectional RNNs. So this might be one potential application. Sorry. So Jack asks, what does embedding mean in this context? So embeddings and vectors, when you're talking about words and meanings, are basically the same thing. So it is the idea that words that are used with other words are more alike. So you can take a large corpus and say, oh, word A and word B are used together so often, word B and word C are used together so often, and go through and create a co-occurrence matrix, and then cast it into a smaller multidimensional space, right? So if you have 10,000 words, like distinct words in your corpus, you could have one matrix that is 10,000 by 10,000, and then each row and column tells you how many times each word occurs together, or you can reduce that down into a more dense space that takes less space in your memory. And that's sort of what embedding is, to take these co-occurrence matrix. Oh yeah, of course. So I'm pasting the GitHub link, which if you can't see is, I'll go up here, Chai-T-Joe or Chiat-Joe maybe, and then LSTM context embeddings. So for words, you can use co-occurrences. Sentences are a little bit trickier. And the reason that people use embeddings in NLP is to sort of tell you about meaning. And there's a couple ways of getting from words to sentences, and one is to sort of do, basically, you can take the embeddings of multiple words and sort of, create a larger vector from those, or you could do the whole sentence as a single embedding, and the sort of, language is really complex, right? And even if you have a really large multidimensional space, it's hard to get all the nuances of language and like things like agreement in just an embedding. But if I were to do it, I probably would use something like this. So bidirectional, specifically LSTM, which is long short-term memory, which is a flavor of RNN, which is a recurrent neural network, is for most NLP tasks right now more or less state-of-the-art. And there's, some different tasks have different applications. Yeah. So, there's a blog post. I do like a blog post. There we go. Here's another way of saying what I was saying earlier. A word embedding is a parameterized function which maps words in some language to high-dimensional vectors. Okay, so what he's doing is taking a specific word and then modifying it based on its surrounding context. So this seems like it would be useful for sense disambiguation. So that's something like the example everybody uses is bank, like river bank versus the bank you put money in. So if you were using the surrounding context, you would sort of take your word bank, and if there were a lot of words like river and ratty and mole and the wind in the willows near it, you would sort of move it closer towards that part of the meaning space in as far as embeddings capture meaning. And if you had like money and Scrooge McDuck and Zuckerberg, you'd move it closer to that side of the or that area of the meaning space, and it sort of take this form that is the same, and depending on its context, sort of bump it over. Yeah. Again, it's, I don't know, language is complex, and I like to dig my heels in just a little bit at some of the neural methods that people use, but I don't know, I also spent a lot of my education building rule sets, so I have perhaps a bias here. Okay. And just giving this a sniff test, it looks good to me. Like, I haven't used it, but yeah, I would. What are you? Okay, so they're using pre-trained word-to-vec embeddings and sort of updating them. I'm assuming they're using Python. God, if they're doing this in Perl. Yeah, TensorFlow. Yeah. Yeah, this looks good to me. Yep, so that's what I do. And I'm a big fan of course, with proper citation and where the licenses allow, using existing code rather than writing my own. Yeah. And you could do this in kernels if you wanted. I'm trying to see if he's parallelizing. I'm assuming. Oop. I didn't actually want to go up. Oh, I don't actually see anything. Do you guys? I think he's just doing this on a CPU. Sequence padding. So everything up to here is pre-processing of the data. No, God, don't sign yourself up for Perl. George, don't do it. Yeah, give it a try. Let me know how it goes. All right. Okay, so let's look at this question. It's from Shisher. I don't know. That seems Beijing-y to me, roughly. Okay. I've been working with data analytics industry for quite a long time, and the major issue most of the customer face is concatenating data coming from multiple sources. Yeah, absolutely. Thank you. I appreciate the emotional support. Tremendo Days is providing us with emotes. All right. For example, a supplier is associated with multiple business units in an enterprise, but it is registered with different names like ABC Inc., ABC Corp., ABC, etc. Now when we aggregate data, conventional systems treat an individual entity, but I'm assuming that's by aggregating it together. Is there a way to manage this using machine learning algorithms where auto-detecting and combining this together can be automated? There is. This is called entity linking, is the name of this specific NLP task. Entity linking. Oh. What I will do is I'll just check and see if this person has written any kernels. And if so, what language? Joanne asks, is there anywhere I can watch past broadcasts? Yes. Oh, they follow me. And David Robinson. Do I follow? Yeah, I think I do on my other account. David Robinson was formerly at Stack Overflow and is now at Data Camp, and you may know him as D-Rob. And before I forget, let me show youtube.com/kaggle.com. So the Twitch streams get... Oh, shh. Hopefully you guys didn't hear just like the music playing. Get deleted after a while. So we have a YouTube playlist that I've posted a link for in the chat. And this one is a little bit grainy. Hopefully they're getting better with the quality. Yes, so I try to keep more or less up to date with the things in the YouTube. Okay, yes, we're working with this. This specific task is called entity linking. And let's find... Oh, right, I was looking to see if they had written any kernels, and it looks like they haven't. So I don't know whether to recommend something in R or Python for them. What I can do is... I want to find like sort of a blog post I can point them towards that has like sort of like the one I did for time series anomaly detection. That's just like, here's a bunch of approaches. And I don't like to send people academic papers if I can avoid it, unless they're super readable. Well, I'll start with Wikipedia. Ooh, actually, let's try Gate as well. I think this is probably going to be slides. Yeah, there's talks in the UR. It is. Oh, and look, there's CC by NCND. That's nice. I can share them, or I could use them in my own stuff if I want to do, as long as I cited them, didn't sell whatever I was doing it, and ND. Didn't make derivatives. Yodai, how we approach entity linking. Some taggers by other groups that are integrated into Gate. Introduction. All right. Oh yeah, this is a really good overview slide. So this is more generally applied to sort of, longer texts than to specific columns in a data frame, but it can be pretty useful. And I think this particular approach is based on a knowledge graph. This may be overkill for this particular person's question. So ontologies are ways of organizing information about a specific entity in the world. So semantic search, if you guys are familiar to that, is ontology based. So the idea is that sort of every entity in the world should have this, data structure associated with it, and you can search through data structures and related data structures. And we actually have on Kaggle, I think we have an anime ontologies data set. Yep. I know this because I uploaded it. So we can sort of show you what that looks like. And the idea with a lot of entity linking approaches is that you can take this information in a database that you have, or some sort of data structures you have, and use that information to figure out, oh, this particular word set is probably attached to this particular, entity in the world. I'm trying to say entity because it's not just like people or businesses. It could be like, objects like apples. What qualities does apples have? And there's this whole really interesting, community around ontologies in particular. So you can see sort of information on this particular 1,000 years later, probably an anime. So there's different types of information associated with it, like how many episodes it has, its title, a description of it, when it stopped airing, the sort of some of the URLs associated with it. And I think their particular approach is to use this knowledge about the world and, figure out what you were referring to when you say Paris in this example. So I think name variation is probably the thing that's going to be most useful. So if we can't find something that just does this, because we don't actually need to do like full-on, parsing a document, like a big text document, being like, oh, these particular words are referring to this particular entity. I think that might be a little bit overkill for this question again. All right. Based on a data source / knowledge base like the ontologies we were just talking about. There was tag me for entity linking, George says. Tag me. Probably not that one. There we go. It's thinking. All right. Ooh, that's very small in the text. Tag me is a powerful tool that is able to identify on-the-fly meaningful short phrases called spots in an unstructured text and link them to a pertinent Wikipedia page in a fast and effective way. Oh, that's cool. And there are some Italians, this is also from George, parsing text to RDF with entity linking. Fred. This is also very small. Fred is a machine reader for the Semantic Web. It is able to parse natural language text in 48 different languages, that's pretty good, and transform it to linked data. It is implemented in Python and available as a REST service and a Python library suite. Oh, cool, I wasn't familiar with this project. This is really chill. And there are relationships, event extraction by using frame detection. Oh, it's frame-based. Gotcha. Frames events. Okay. So frames is this idea in linguistics that's pretty strongly associated with Berkeley. At least in my mind. Interesting. Yeah, this is really neat. Ooh, named graph generation. That's cool. Word sense disambiguation. So that's like bank I was talking about earlier. Ah, this is neat. So I'm just looking at the papers that these are published in, and I can see why I have not run into it before, because these are not generally the specific, these aren't really the journals and conferences I keep on top of. I don't even know what EKAW stands for. European Knowledge Acquisition Workshop. Interesting. European analog to the Knowledge Acquisition Workshop series of workshops in North America and the PKAW series in the Asian Pacific area. Knowledge-based systems in the 80s and 90s, in particular for those researchers who are especially interested in the issues associated with computational representation of knowledge and human expert behavior. Interesting. Okay, so this is way over on the semantic side of things. Cool. Oh, anyway. I think this is going to be, this is fascinating and super good to know for me. But I think it's going to be a little bit overkill for this particular person. I think what they want to know about, or what I think it would be most useful for them to know about, is probably edit distance. So I think they should know about entity linking. Well, actually, let's give it a try. So there's a little tag me here. So this is only going to work with things that are already in the knowledge base. So if I don't know about ABC Inc., ABC Corp., ABC, etc., it's not going to get tagged because it doesn't have a knowledge base associated with it. Yeah. So it's not, identifying that these are all values associated with a specific company. Yeah, I think edit distance might be more helpful for this person. So edit distance is just the number of characters you need to change one text string into another text string. And here's the tab. If you have a lot of unstructured text documents, like emails, newspaper articles, etc., you can try some of the entity linking approaches. Is that right? It's not checking spelling. Oh, yeah, it is. Because I have emails here. And I'm going to shamelessly steal George's very good recommendation. Like, what was it? Tag me. Nope. Tag me, which you can try here. On the other hand, if your data is just in a, if you're trying to identify, what would you call it? Cells in a spreadsheet and don't have a lot of text for each, a lot of text in each cell, you could try to use edit distance, or how many characters you need to change to make one name into another name to duplicate your cells. If you're using Python, list of challenges. It's not how you spell day. It's not gonna work. Let's do it in here. List of 5. There we go. In the Python data cleaning challenge, I've talked about this in inconsistent data entry. So I can give them a nice little here's how to, and I won't have to type out the whole answer again. Here's a kernel that walks you through yeah, I think I'm gonna just get rid of this. I think it's more useful to say fuzzy matching. Walks you through how to do it. If you prefer R, this might be helpful. And I also have a deduplication kernel in R that should be at the bottom. I don't want the code, I want the notebook. This one. This is the sort of thing I would usually do in Python rather than R. All right. That looks good to me. I closed all my parentheses. I think that one's good. All right. It is 4:46. Does anyone in the chat have a question? If not, that's fine. I'm sure there are more questions on the forums. This sounds like a potentially a notebook specific question. I already answered that one. Oh, here's a good one. How to use Chi-square to on categorical variables. Oh, I should also check Twitter really quick. I'm going to do that in a different window. And if there's nobody on Twitter, then I'm going to work on this Chi-square one. Okay, we do have a question from Tunde. At what point does one carry out hypothesis testing on your data during machine learning? And if data is positively skewed, don't I need to make the data a normal distribution? All right, so let me put this in here. And we'll come back to the chi-square question if we have extra time at the end. Okay. And let's make it bigger. Bigger. Even bigger. There we go. Oh, this is a really good question. It depends. Yeah. So there's kind of, I don't want to say a friendly rivalry, because that's not really a rivalry, but there's a little bit of a tension between the machine learning community and statistics communities. Not even a tension, it's just like they use a lot of the same techniques and have sort of the same like underlying goals. Like the idea in both cases is to sort of represent information about the natural world in a compact mathematical way, right? To quantify and condense, knowledge in a useful way. But there's also a pretty, oh no, my foot's asleep. There's also a pretty, I'm just gonna shake it until it stops tingling. Strong divide in sort of like how central uncertainty is. So in statistics, it's really core to the practice of statistics to highlight how uncertain you are in a specific situation, right? So you'd never say, I'm trying to think of a thing you'd never say in statistics. You'd never report just a mean and not a standard deviation, right? You want to say, here's what things usually do, and here's how much, variance there is in the data. Here's how uncertain I am about that. Kind of. Standard deviation isn't exactly uncertainty. But it's sort of very much focused on accounting for and describing the amount and direction of wobbliness in the data. You know what I mean? And in machine learning, that is much less of a focus. And I wonder if partially this is because it is a computational discipline, and if you have the same data and the same code and you run it 2 times, you're going to get the same result. You're not going to sort of unless the code is updated, you're not going to see the variation that's in the world. You can exactly replicate your work. Whereas in the social sciences or medical science, there's no way that you're ever going to completely exactly reproduce an experiment, because you're going to have different people. Air pressure might be different. There's a lot of complexity in the natural world that doesn't exist, on a computer chip. So machine learning is definitely something that's, I think people are aware of, but it's not the central idea of the field. And the reason why I'm talking about this so much is because hypothesis testing is a way of sort of stating how uncertain you are, right? and it's not a central part of machine learning. So often it just won't happen. And if there is any hypothesis testing, it'll just be like, was our model better? Yes, like the most frequently used statistical hypothesis test in ACL papers is a t-test, and it's student's t-test, which is sort of the most basic way of seeing if two sets of numbers are different. It's what you'd learn like the first week of statistics class, and sort of more, not that there's not fancy math, but there's not a lot of, fancy hypothesis testing. So one place where it does happen, if you are doing machine learning specifically, is sometimes for variable selection, right? So you see which variables you are fairly certain have a large effect, and you can choose to use those as opposed to the others. Yeah, so that's sort of a very long-winded answer to the first question that says usually nowhere, sometimes during variable selection, and sometimes during model selection, so picking which model is the best, or, in academic work, showing that your model is better than the other models, because otherwise you probably won't get published, which is, its own set of biases that I have my own feelings about. So the second part of the question is, if the data is positively skewed, don't I need to make the distribution a normal distribution? Sorry, the data a normal distribution. Not necessarily. So there's a lot of statistical tests that do assume that your data is drawn from a normal distribution. And the reason for this is that it's really nice to do math with the normal distribution because it's symmetrical and it's centered around 0, and it has lots of, well, not necessarily centered around 0 all the time, but you can transform it so that it's centered around 0. And this has, it's nice to do math too. But the types of tests that assume that you have a specific distribution of your underlying data are called parametric tests. And you can get around by having to transform your data to make it normal if you just use non-parametric tests. So I'm going to, after having spent 10 minutes saying those things, tweet the replies. So, hypothesis testing isn't always part of machine learning, but when it is used, it's usually during variable selection and maybe model selection when you're comparing two. Well, I think that's terse. I think that's fine. And then the second bit, you only need to transform the data to a specific distribution if you're using a parametric technique that assumes your data is drawn from that type of distribution. You can get around that by picking a non-parametric method instead of transforming your data. And non-parametric methods, the reason that you wouldn't do that is that they generally need more data points. Oh, did it disappear? No, my tweet. Okay, I'll type it out again. You only need to transform your data into data into a specific distribution if you're using a parametric method that assumes your data is drawn from that distribution. You can avoid having to transform your data by using a non-parametric tick in the queue instead. Man, I really like to think that there's two O's in distribution. The reason you wouldn't use a non-parametric distribution just like all the time is because you need more data to get the same amount of power. Has anybody else asked me a question? On the Twitter? Nope. Okay, we're good to go. Chisquare time. Unless somebody in the chat has a question. We got 3 minutes, so this is going to have to be a quick one. Nobody yet, but if I see one, I'll pop in. Aw, well, welcome, Kunli. Kunli? I don't know. Hi all, this is my first question on this platform, and I am a newbie in data science. Welcome to the field. Can anyone please explain how to use a chi-square on categorical variables in order to fit the best categorical variables and to avoid overfitting? Thank you. So chi-square is for I wouldn't really use it for variable selection. I guess you could. Well, let's see. Chi-square for chi. So chi-square is usually for hypothesis testing, the thing we were just talking about. Chi-square for variable. There we go. Oh, entropy-based methods. Can I see anything more recent than 2011 though? Because that's like the 1910s in terms of like machine learning. 2015, 2017 on Stack Exchange. I'll see. 77. Oh my god. Also, I would never, again, I don't like to send people academic papers in answer to their questions, unless we've been like talking back and forth. Wow, this font's tiny. Blah, 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 blah. Cursor dimensionality. That's just you have a lot of variables. Blah, 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 blah. Entropy-based methods. Process involves computing Shannon entropy for all variables. For each pair of variables, for a total of p times p minus 1 divided by 2, mutual information is computed. Finally, these variables, which contribute more than a given fraction of overall information exchanged within the dataset, are selected as the key variables. Again, 2011. Is this approach to select variables wrong? Do a chi-square test of dependent variable versus independent variable and only use those variables which show a dependency. Similarly, use a t-test to see if continual variables are actually different when y into variable is either 0 or 1. This question was marked as an exact duplicate of an existing question. Whoop. This is a version of variable selection via hypothesis testing. Logically, it is the same as and has the same problems as stepwise methods. And the problem is multiple comparisons. Rude. That's so rude. So this answer says, frankly, I think this is a disastrous idea, just about guaranteed to lead to many false conclusions. That's so rude. I don't know. If I asked my first question and I got that answer, I would be, sad. I'd feel bad. I wouldn't ask any more questions. More chitter chatter on stepwise regression. I don't know if this is going to be a useful answer to give them, though. Because then, so this person asked basically the same question, right? And then, the first answer that they would see would be this one, which would lead them to think, oh no, maybe I'm not doing it good. I'm trying to think what the best thing to do is here. I think the best thing is to point them towards a different technique that might be more useful. Without, this is a good question. It makes sense, right? So Chisquare tells you about categorical variables and whether categorical variables are for, whatever dimensions you're interested in, whether they're sort of, similarly distributed as you vary your interesting dimension, or whether they're sort of you think that they're probably drawn from independent distributions, right? If we had a categorical variable owns dog toys, so yes or no, do you own any dog toys? And then we had another variable, do you have a dog or not? We wouldn't expect that the same proportion of people who don't own a dog would have a dog toy as the proportion of people who do own a dog have a dog toy. So we would say that these would be independent, right? They're drawn from different populations, and there's a strong difference between them. And it sort of makes sense that you would use that for variable selection, but if you have enough variables that you're doing variable selection, you probably don't want to be doing hypothesis testing to do it. Is there a learn lesson on variable selection? That might be more helpful for this person. This is the learn discussion forum and not the learn forum. I think I'd probably be in here. Underfitting, overfitting, model validation, selecting and filtering. I think that's just by hand. Categorical data, pipelines, cross-validation, data leakage. None of those. Do I do variable selection in my lessons? Visualizing data, NLP. I don't think I do. Well, Carrot is kind of, no, Carrot doesn't do variable selection. Carrot does hyperparameter selection. I'm going to think on how best to answer this question, because it's after 5 now, and do some ruminating and do it tomorrow. But anyway, thanks for joining me, guys. This was a lot of fun. I don't know, maybe I'll be back to my reproducible research project next week. We'll see. It's a lot of brain, and it's hard to do live. So we'll see if I have the mental energy for it. So thanks so much for joining me, and I will see you guys next week. Bye.